Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everyone, and welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And we just love what we get to do, which is help you feel more competent and confident in your math skills, helping you feel more competent and confident in your math skills. So that's why we're here. We are here every Wednesday, just going through different math problems anywhere from pre-K through 12th grade, just to help you feel more competent and confident, more successful as you walk into these difficult math exams. I am from Central Florida. And if you can't tell, I love Christmas. I love the holiday season. I love Christmas. And my son loves Christmas just as much as I do. So he was wandering around the house with these silly glasses on the other day. And I was like, oh my gosh, I'm going to wear those just for a little bit. I mean, I'm going to take them off now because, I feel like I have bug eye. Like, it is like hard to see in those things. It's like legit, like a bug's life, like bug eyes. It like makes everything distorted. But I love Christmas so much. I love the holiday season. And so it is December, and that is why I wore Christmas glasses. So in the comment box, let me know a family tradition that you have. I always love to do a get to know you question because it feels a little less like a computer screen and a little bit more like we are sitting together in a living room. So let me know in the comment box, where are you from? What test are you prepping for? And what is a tradition that you have, or what holidays do you celebrate? We obviously celebrate Christmas in our house, but we also recognize that not everybody celebrates Christmas. Some people celebrate Hanukkah. Some people don't celebrate at all. Some people celebrate the Chinese New Year. And so I would love to know, what holiday do you celebrate and what traditions do you have in your family that you love? I think a silly tradition that we have is every day we open up a it's just wrapped in brown paper, but it's a Christmas book, a holiday book. And so my son gets to unwrap one every day until we get to Christmas. And so that's a fun holiday tradition that we have. What is a fun holiday tradition? It could be that you just get together with family or something like that. And what holiday do you celebrate? And what test are you prepping for? I mean, more importantly, because that's why we're here. In the comment box, you can also let me know anything that you want to see me go over in the upcoming weeks. I always have a next week section. And so in the comment box, let me know, what do you want to see me go over in the upcoming weeks? I would love to know, because that helps me guide these sessions and make them more applicable for you. And so let me know what you want to see me go over in the upcoming weeks. Without further ado, let's go ahead and get started with our first problem of the evening. Phoebe is trying to put carpet down in a room that is shaped like the shape below. How much square carpet will Phoebe need for the room? How much square carpet will Phoebe need for the room? 336 feet squared, 408 feet squared, 578 feet squared, or 952 feet squared. All right, so as we look at this problem and we solve it, there's a couple of different ways that we can approach this problem. This is a problem really for my elementary people. However, the concept is really something that we all need to be aware of. And so when we look at some basic definitions, how much square carpet, they could have even just said how much carpet, and we would have had to interpret that they are looking for square carpet. Anytime I see this word square when it's in relation to something like this, I immediately think area. Area is a square measurement, perimeter is a linear measurement, and cubes are a volume measurement. And so how much square carpet, I'm looking for the area of my shape. Now, depending on the test that you are taking, will determine if you have a formula sheet or not. Some of you have a formula sheet and some of you do not. If you have a formula sheet, you most likely have something that looks like this. Area of a rectangle equals length times width. Now, if you don't know what length or width are, or you don't know how to use these formulas, the formula sheet really does you no good. And so it's important for you to understand what the formula sheet is and why it, how it works and how it operates, because otherwise you're really going to end up struggling and the formula sheet's going to be useless at that point. So the area of a rectangle is length times width, but I can promise you on your formula sheet, you're not going to see area of an oblong shape that looks like this. And if you don't have a formula sheet, you should know that the area of a rectangle is length times width. So I can approach this problem two ways. I can look at it and say, I have a length and I have a width. And I could find the area of that whole rectangle that I just traced by doing length times width, and then finding the length and the width of this smaller rectangle and subtracting it out of the bigger rectangle. That is one option. That's not my favorite option. I don't know why, it just isn't. And so that's never the first direction that I go when I solve these problems, but that's one way that you could solve it. The way that I typically approach these types of problems is I like to divide my weird looking oblong shape into two smaller rectangles. So often I'll do something like this, where I say I just created a pink rectangle and a green rectangle. And now I can find the length and the width of the pink rectangle and solve, the length and the width of the green rectangle and solve, and then I can add them together. I prefer this method because if I have a shape that looks like this, and I think it just disconnected, it did. So let me reconnect here real quick. I prefer the addition method over the subtraction method because there's a lot of other shapes. There's a lot of other shapes where the addition method is actually a better method. So like if I had a shape that looked like this, I can't use the subtraction method for that shape, but I absolutely could use the addition method and do the area of the square and the area of the triangle. So I just happen to usually look for composition rather than decomposition. Composition is the addition of shapes or the combination of something. Decomposition is the deconstruction of something. And so I'm going to look for, here's an length 12. So I have 12 times, now my width is 17. That was easy peasy. Now I'm going to use my calculator because I do have a 4-function calculator in front of me. So I'm going to use my calculator and do 12 times 17, and that equals 204. Now I need to find the length and the width of my green rectangle. It is very clear that they didn't give me a measurement for this or for this. So I'm going to have to do a little bit of manipulation here. I know that this entire length is 17 because they told me that over here. And what I do know about a rectangle is that the opposite sides are going to be congruent. The opposite sides are going to be congruent. I know that my width is 34 on the top, the whole thing. I also know that this section right here is 6. Because that right there is 6. Which means I can do my whole, which is 17, subtract the 6 out, and it will leave me with my other part. This, for my elementary people, should look very familiar. This is your part, whole model. Part, whole. It also often is represented in a tape diagram, which looks something like this, where you have your whole on the top and your parts on the bottom. That's all this is. So 17 minus 6 is 11. This is 11. This is clearly not drawn to scale, and we wouldn't expect it to be. A lot of times things are not drawn to scale when we're doing geometry. Now I'm going to use that same concept, and I'm going to know that this whole thing is 34, but if this is 12, this whole thing is 12, and I can do 34 minus 12 to give me that other part. 34 minus 12 is 22, so this piece is 22. So I know I have 22 times 11 equals 242. Now, how do I find the entire carpeted area of this blue shape? Do 204 plus 242. And that's going to equal 446. Now, I changed the numbers and did not change my answer choices. So we're just going to do a little bit of this and do 446. Let's see. Questions? All right, let's move on to problem number 2. Phoebe is now not trying to put carpet down. She's trying to put baseboard down in a room that is shaped like the shape below. How much money will the baseboard cost if the baseboard is sold in 3 feet sections at $16 per section? How much money will the baseboard cost if the baseboard is sold in 3 feet sections at $16 per section. So now when I see the word baseboard, I'm immediately thinking, I know what to do. That is my perimeter. So because I see baseboard, I immediately think baseboard just goes around the perimeter of the room, right? Now, they're clearly not asking how much baseboard would she need if she makes cutting errors or whatever. You and I both know that that absolutely happens when there's a project. But we're looking for, in the perfect world, how much baseboard would she need? And so that's the type of problem we're solving right now. Now, in our previous problem, we had already solved that this was 11 and that this was 22, because remember we did that 11 times 22 rectangle. But you would do the same process for this to find out those missing sides so you know the lengths of those sections for your baseboard. So the question is, how much money will the baseboard cost? If the baseboard is sold in 3 feet sections at $16 per section. This is a multi-step problem. Let's first figure out how many feet we have in our room total. Let's just find the perimeter. So I'm just going to add up all of my sides. So I'm going to do 34 plus 17 plus 12 plus 6 plus 22 plus 11. So I'm going to use my calculator. 34 plus 17 plus 12 plus 6 plus 22 plus 11. And all of that equals 102 feet. Now what? I'm not going to multiply that times the cost because it said something interesting that we don't want to miss. The baseboard is sold in 3 feet sections. Y'all, this is a really, really good multi-step problem that really helps all of us, even though you may not be an elementary person. Looking for those small details that are going to drastically change the trajectory of the way that you solve the problem is key. So this baseboard is sold in 3 feet sections, which means I need to take my 102 feet and divide it into 3 foot sections so I know how many sections I'm buying. And you're noticing that I'm very clearly labeling everything that I'm doing. That is a key point in all of this, because otherwise, when you're solving long multi-step problems, you can get lost in the weeds. 102 divided by 3 is 34. I need 34 sections. Now, at $16 per section multiplication, I can just do 34 times 16, and I get $544. Now, I have an interesting question for you. What if we divided our amount by 3 and we got 34.2 sections? What would happen then? What if? This is a what if. We solved and we got 34.2 sections. What would we do then? Would we round down and still multiply the 34 times the 16? We would not, because if we did that, then we would end up with not enough baseboard. This 0.2 are critical feet in my room. I didn't add any extra in. So if I only buy 34 sections, I'm going to have a gap on my wall. So in this case, I would actually still round up to 35 and do the 35 times the 16. Now, if it said round to the nearest section, then you would round to 34, because when we round, 4 or lower rounds down, 5 or higher rounds up. But we would only do that if that's what it said. But when we're solving real world problems, we have to understand when we're rounding and what the concept is behind that. And we have to round or estimate according to the problem. So if we rounded down, we would end up with not enough baseboards. So that's interesting for us to consider as we're solving these types of problems. Let's go ahead into problem number 3. Lines P and Q intersect at point X, Y at a 90-degree angle. If the slope of line P is symbol over symbol, what is the slope of line Q? If the slope of line P is symbol over symbol, what is the slope of line Q? So you'll notice that I said that kind of funny because I don't want to butcher the symbol names, and I don't actually know the Greek alphabet. Shocker, I know. But I'm saying all of that because I need you to know that just because you don't know these symbols doesn't mean you don't understand the concept of this problem. When we look at this, if we know that they intersect at a 90-degree angle, what does that mean? These are perpendicular lines. And so what do we know about perpendicular lines? We know perpendicular lines have negative reciprocal slopes. So if the slope of one line is 2/1, then the slope of the next line is going to be negative 1/2. So if the slope of line P is this, then the slope of line Q is going to be the negative. There is no negative applied to this, so it's just going to be negative. Reciprocal. Flip it. That's my answer. Don't overthink it. Just because you don't know the symbols or you see something that looks foreign doesn't mean you don't know the concept. This right here was a level 1 recall problem. This right here was a level 1 recall problem that so many people skip because they think they don't know it. All they were asking is, what is the slope of perpendicular lines? And all we had to do was know that. But it's intimidating. We don't know it. We see these symbols, and even me, I'm telling you, even me, we look at it, we go, I don't know how to do that. No way. Jose. Absolutely not. And if we just allow our brain to say, hey, you know this, and get ahead of it, we can do it. Let's move on to the next problem. Don't freak out over this one. We just talked about how to do it. Lines P and Q do not intersect. If the slope of line P is, I think that's theta over W, what is the slope of line Q? You know how to approach this now. If they do not intersect, that means that they are what? Parallel lines. And if they are parallel lines, what does that mean? Parallel lines have the same slope. Did it just disconnect again? Yeah. Let's reconnect. And then we will keep going. So parallel lines, y'all, have the same slope. So if the slope of line P is theta over W, then the slope of line Q is going to be theta over W. We don't need numbers to figure that out, right? We don't need numbers to figure that out. We can do it. And that's what I want you to understand, is that you don't need to, you don't need all of that information. You're fine. You can do it. All right, what is going on? Let's go ahead and fix this real quick, and then we will be good to go. While we're waiting, let me know in the comment box, what do you want to see me go over in the upcoming weeks? What do you want to see me go over in the upcoming weeks? What topics are you like, man, I just wish she would go over this. She never goes over this. Or, man, if only we did this, I would feel a little bit more confident. Let me know in the comment box. I want to help you. So let me know so that I can best cater these sessions to you. There we go. And I just threw my pen. Let's go ahead and move on to, oh, we never answered it, but we already talked about how we know if the lines are parallel, they're going to have the same slope. So it's going to be the same thing. All right, let's go on to the next problem. Sophia is solving a system of equations and gets a result of 3 equals -7. What does this mean for the system of equations? What does this mean for the system of equations? This one is such a good one. So, systems of equations are really fun, honestly. So if we get something like this, a system of equations is just 2 equations, could be 3, but in this case it's 2. 2 equations that when we solve them, we can find out their intersection point. When we solve them, we can find out their intersection point. And so if I have 2 equations graphed on the same line, and when I solve my system of equations, my solution is this point right here. However, what happens if I have this? Or what happens if I have this? I don't have necessarily an intersection point in that case, do I? This means the system of equations does not work and cannot be solved. This means that the lines represented by the equations are perpendicular. This means that the lines represented by the equations are parallel. This means that the lines represented by the equations are coinciding. This is coinciding. This is parallel, and perpendicular is specifically intersecting at a 90-degree angle. I can tell you right now, it's not A. The systems of equations always work. It might not be pretty, but you can always solve your systems of equations. So are they parallel, perpendicular, or coinciding? Well, if I get a result of 3 equals -7, then I get a situation where I don't get x equals or y equals, which means my lines are parallel, and I'll explain why in a minute. If they are perpendicular, I'm going to get a singular intersection point, correct? If they are perpendicular, I'm going to get a singular intersection point. So I'm going to get x equals blank, and then I'm going to finish solving it, and I'm going to get y equals blank, right? If they're coinciding, I'm going to get 3 equals 3, 0 equals 0, x equals x, 9 equals 9. Because no matter what, it's equal to itself. But if I get two things that are not equal to each other at all, it means that those systems don't intersect because they are parallel. All right, we have time for one more problem, and then I'm going to turn it back over to Dr. A. Maximus makes $35 for every unscreened pool he cleans, and $20 for every screened pool he cleans, and an additional $10 for pressure washing the deck. Maximus is currently servicing 9 client pools. He cleans 5 unscreened pools and 4 screened pools, and pressure washes 3 of their decks. How many more dollars will Maximus make if he raises the cost of the unscreened pools to $40, the screened pools to $30, and begins to pressure wash 2 more client decks? So this is one of those multi-step problems again. It says, how much more will Maximus make if? So in order to solve that, I have to figure out how much Maximus is making to start with. So to figure out how much Maximus is making to start with, he's cleaning 5 unscreened pools, 4 screened pools, and 3 decks. So I'm going to do 5 times 35 because it's $35 for each multiply of the unscreened pools. 4 times 20 and 3 times 10. This equals 30. This equals 80. And this one equals 175. Add them all up, and I get $285. This is how much he was originally making. Now, how much more will he make if he raises the cost of unscreened pools to $40, screen pools to $30, and adds 2 more client decks? Well, the client decks are still $10, but he adds 2 more. So now instead of 3, he has 5. And he's still doing 4 screened pools and 5 unscreened pools. But now the unscreened pools are $40 and the screened pools are $30. Now I'm going to solve that. 200 plus 120 plus 50 equals $370. How much more is that? Subtract the original from the new, and I get $85. That was kind of a fun problem, wasn't it? All right. Let me know in the comment box what you want to see me go over in the upcoming weeks. I would love to add it to my next week section. And I look forward to seeing you again next week for Math Wednesday. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. but this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.